Hi class, so today I'm not actually going to do the last page in our notes. I'm actually going to look at proving trig identities, primarily because lots of students find this really difficult, and there is a whole chapter on it. Exercise 7F is on it and we've not touched it, so I thought rather than doing the last page, we'll do these examples and then I'll ask you to do some questions from exercise 7F. In my opinion, to get really good at doing proof, you need to have done about 100 of these proof questions before you get adequate at them. If you want to be really good, 150 to 200. Okay, I know it sounds like a lot. I'm not joking. This is how many you would have to do, so you become fluent in it. Okay, so let's have a look at that first one. So I'm just going to click on the screen. It says, show that 2 sine theta over 2 cos theta over 2 times cos theta is a half sine 2 theta. Okay. So I've copied out here. With proof questions, you start on one side and you try and aim for the other side. Okay, so what I'm going to do is, I think I'm going to start on this side here. So I'm going to start on this side here. So I'm going to start on the left-hand side. And this one here, this part here, I'm just going to look at this bit here. Okay, so that bit there, 2 sine A cos A. Now I know 2 sine A cos A is one of my double angle identities, is sine 2A. Except here, A is theta over 2. So I'm just writing A is theta over 2. So this bit here, the bit that I've drawn a square around, I'm going to write is sine of 2 lots of A. So I'm going to write that's sine of 2 lots of A. So that's 2 lots of theta over 2. Okay, like that. But I still have a cos theta multiplying it. So I've got times cos theta. I'm just going to tidy up a little bit. So that there is sine theta cos theta. Okay, like that. Now sine theta cos theta, well, that's neatly sine A cos A, 2 sine A cos A, except it's half of that. So here what I'm going to do is I'm going to say that this is half of 2 sine theta cos theta. This bit here is sine 2 theta. So I've got half of sine 2 theta, which is the right hand side. So I've proven it. Okay, so that one's done. All right, let's have a look at the next one. I have got 1 plus cos 4 theta is 2 cos squared 2 theta. Okay, so I'm going to pick a side. Which side am I going to pick? To be honest, it doesn't really matter on this one. I think I'm going to go crazy and I'm going to pick this side here. And what I'm going to do is I'm going to use the cos 2a identity. Now, cos 2a, there are 3 different ways of writing cos 2a. Okay, there's cos squared minus sine squared. There's 2 cos squared minus 1, and there's 1 minus 2 sine squared. Okay, so I'm going to pick the one that has cos in it. So I'm going to write that this is 2 cos squared A minus 1. That's the trig identity. You do have to learn these. That's the one I'm using because I know my answer has to have a cos squared in it. Okay, now if you have a look at this bit here, if 4 theta is 2a, I'm just going to write that out. If 4 theta is 2a, then A must be 2 theta, okay? So I'm just going to write that whole bit out again. So I've got 1 plus cos 4 theta, okay? 1 plus cos 4 theta will be the same as this bit here, okay? 2 cos squared A being 2 theta, and I've got my minus 1. 1 take 1 is nothing. So I have got 2 cos squared 2 theta, which equals the right hand side, and QED. Here you go. Okay, so that one's done. I'm going to look at the next example. So I'm going to look at example 19. So prove the identity tan 2 theta is the same as 2 over cot theta minus tan theta. Some of you might be wondering what's with the 3 lines. I think I might have explained it before. Normally you have an equal symbol. This here, with an equation. So if you had an equation, so I'm just going to do a really simple equation here, 2x plus 1 equals 7. If you rearrange that, you would get x is 3. So this equation is only true when x is 3. Okay, so this is an equation. When it's true for any value of x or theta, they call that an identity. Okay, so these three symbols means it's an identity. It means it doesn't matter what theta is, these two will always be the same. Okay, so I'm going to go to that example, tan 2 theta. I'm going to pick a side. I think I'll just stick to that because I know what tan 2 theta is. It's one of our trig identities that we have to learn. I'm just going to write it down. Tan 2 theta I know is 2 tan theta all over 1 minus tan squared theta. Okay, so that's the identity. So I'm going to start with the left-hand side. Okay, and I need to make it look like that. So I'm going to look at this and I'm going to look at that and I think, well, how am I going to get from there to there? Well, I have a 2 on the top there, but I have a 2 tan theta there. Well, how about I divide everything by tan, top and bottom? Because I can see that one, if I divide that by tan, I'll get 1 over tan, which is cot. And if I divide this by tan, I'll get tan squared over tan, which is just tan. Okay, so what I'm going to do, I'm going to write it here. I'm going to divide both top and bottom by tan theta. Okay, so if I do that, I am going to get, and I will do it in full so you can see it really clearly, 2 tan over tan divided by 1 over tan minus tan squared over tan. Cancel down anything you can. So I have got equals 2 over cot minus tan, which is the right hand side, QED. Okay, last one. So we're going to do one more example. I think it's example 20. That one there. What does it say? Prove that root 3 cos 4 theta plus sine 4 theta is the same as 2 cos 4 theta minus pi by 6. Okay, so I've copied it out. And I think what I'm going to do is I'm going to pick the right hand side. Reason being because I can use the addition formula on that. Okay, so I'm going to say right hand side. I'm just going to make this up a tad. Okay, I've got 2 cos 4 theta minus pi by 6. And I'm going to use my addition formula, which you can look up. I will write it here. Cos of a plus b is cos minus sine. Okay, so a being 4 theta, b being pi by 6. And actually that's a minus there, so what I'll do, I'll change that to a minus, so that makes that a plus. Okay, so let's put it all in. So I've got 2, and then I'm just going to draw my brackets. So it's going to be cos 4 theta, cos pi by 6. So cos 4 theta, cos pi by 6, plus sine 4 theta, sine pi by 6. Close your bracket. Now if you type in cos of pi by 6 into your calculator, I think you get root 3 over 2. Okay, so just you can type that in to your calculator. So you would get cos 4 theta times root 3 over 2. And then sine of pi by 6, that's a half, plus sine 4 theta times a half. And then you can tidy up. You can see that the 2 there would make that 2 disappear and that 2 there. Okay, so you just have root 3 times in the cos 4 theta. And then you just have plus 2 sine 4 theta. Like that. That's odd. Oh wait, 2 times a half is not 2. This is and I've just copied this out wrong as well. And that's it, I've done it. So that is the right hand side. Well, it's the left hand side, isn't it? QED. All right, done. All right, so what I'd like you to do is have a go at exercise 7F for today's work. It's not easy. It's not meant to be easy. Proof is always tricky. I would recommend that you do all of these. You will get stuck. And that's when you check the mark scheme. Some of you are asking me, well, how do I check the mark scheme? There's 2 ways. You can either click on this little icon here. Okay, there's your solution bank. There's your mark scheme. Or you can go to physicsandmathstutor.com So physics and maths tutor, bring it up. It's not hard. Solution bank, so there on the first page, click on there, all right, and just tell them which book you're looking at, Pure Maths Year 2, and whatever exercise you're working on. So you're working on 7E, there it is. I'm surprised you don't already know this. There you go, okay. I think I'm actually on the wrong chapter, but you get what I mean. I think it might be 7F I was asking you to look at. Yes, I was. Okay, so that's the work for today.